Hello dear students, in this session we are going to solve the numerical on conjugate beam method. In this question we are given with a simply supported beam of length 5 meter carries a point load of 5 kilonewton at a distance of 3 meter from the left end. If E is equal to 2 into 10 power 5 Newton per millimeter square and I is 10 to the power 8 millimeter to the power 4, determine the slope at the left support and deflection under the point load using conjugate beam method. So we have to use conjugate beam method in this case, and we are given with a simply supported beam of length 5 meter. Simply supported beam is there, length of the beam is 5 meter, point load is there, the intensity of point load is 5 kilonewton and distance is 3 meter from the left support, right? E is given to us, modulus of elasticity, moment of inertia is given to us 10 to the power 8. We have to find the slope at the left support and deflection under the point load, and we have to use the conjugate beam method, right? So let us solve this problem. In this question, we are given with a simply supported beam loaded with a point load at certain point C point, which is at a 3 meter from the one of the end, and we have to find out the slope at point A, theta A, and the deflection under the load, under 5 kilonewton load, using conjugate beam method. CBM means conjugate beam method, and modulus of elasticity is given 2 into 10 power 5 Newton per millimeter square, and moment of inertia is given 10 power 8 millimeter to power 4, right? So these things are given, and we have to find out the slope and deflection using conjugate beam method, right? So let us solve this question. So what is conjugate beam method? Conjugate beam method, to find out the slope, we have to find out first the slope. So conjugate beam is that beam which carries the load of bending moment. So first we have to draw the bending moment diagram. Now that bending moment diagram will become the load of the conjugate beam, right? And then the width of that conjugate beam is EI, right? So first we have to draw the bending moment diagram for this, which will become the load of the conjugate beam, right? So let us draw the bending moment diagram. So suppose this is the line at which we want to draw the bending moment. This is A, B and C, right? So as usual, take the section at a distance x from one of the end. Say from here we have taken a section x. Take the bending moment mx. So mx will be equal to, before that we have to find out the reaction. We have not find out reaction till now. So what is RA and RB? So first find out the reaction first, right? So before that, find out the reaction. How to find out the reaction? Take the moment of these forces about any of the points, say A point. So moment of all the forces about point A, and that should be equal to 0. So what is moment? The moment of 5 is 5 multiplied by 3. It is clockwise. So 5 multiplied by 3, and RB is anti-clockwise. So RB multiplied by 5. So minus RB multiplied by 5. So this will come out to be, and this is equal to 0. Moment of all the forces about A equal to 0. So 5 into 3 minus RB into 5 equal to 0. So this will come out to be, RB will be equal to, from this RB will be equal to 3 kilonewton. Solve it and you will get 3 kilonewton, right? So this is, RB is 3 kilonewton, right? Next we have to find out RA. How RA can we find out? The sum of the forces in vertical direction should be equal to 0. So sigma F in vertical direction should be equal to 0. So that is equal to 0. So this implies all the forces in downward and the forces upward should be equal to 0. So that downward force is 5, upward force is RA plus RB, RA plus RB, and RB is 3. So this implies RA will be equal to 2 kilonewton. So RA come out to be 2 kilonewton, right? So this reaction at A point is, 2 kilonewton, and reaction at B point is 3 kilonewton, and total force is 5. So that is okay. Now take the section between A and C and find out the moment mx at a certain point x, right? Moment about x will be equal to the force, moment of this force about x, so 2 multiplied by x, so this is 2x, and this will be valid between A to C. This is valid between A to C. So, and if we take the 2 points, that MA where x is 0, so that will be equal to 0 because it is a linear variation, and at C point, this point where x is equal to 3 meters, so this will be equal to 3 to just 6 kilonewton, right? So now from 0 to 6, say this is 6, right? So this distance is say 6 mc, which is 6 kilonewton meter. This is kilonewton meter, like this, right? From 0 to 6, so this is the bending moment, and linear variation is there, x variation is there, right? Variable with respect to x, right? So this is one part of this question, that we have drawn the one part of the bending moment diagram. Now rest of the bending moment diagram should be drawn. We can take x in this part, or we can take x from part A or from position B, right? So it is better to take the position from B because there is only one force in this, so we can take x from B now, right? So we are taking x from B now, so it will be valid between B to C, and that will be equal to 3 multiplied by x, so this is 3x. So MB will be equal to, where x is equal to 0 because we are taking from B, so this is 0, and MC will be equal to, where x is equal to, this part is 2 meters, so this will come out to be 6 kilonewton meter, right? Again 6 kilonewton meter from 0 to 6, so you will get this line now. So this is the bending moment diagram, right? This is the bending moment diagram. Now this bending moment diagram will become the conjugate beam. This will become the conjugate beam of width EI, right? So now our load is this 6 kilonewton meter is our load, and this is our now new conjugate beam, right? And we have to find out the slope at A point and C point, right? And for conjugate beam, the slope at any point is the shear force at that point, right? So we have to find out shear force at A point. So for that we have to find out the reaction. So this is suppose A dash, B dash, C dash. So now this will become a conjugate beam with 6 kilonewton meter of load, or you can make another beam of similar beam, showing that this is now the loaded beam, this is now the conjugate beam. So you can make another beam of same type of beam and showing that this is a conjugate beam, this type of beam with width EI, right? So this is 6 by EI. We can use here only, or otherwise we can later on we can divide, or we can directly use 6 by EI, so that it may become easy. And this distance is 3 meters, distance will remain same, 3 meters, and this distance is 2 meter. This is point is suppose A dash, this point is B dash, and this point is C dash. And we have to find out first the reaction, because simply supported beam, the simply supports will become same for a conjugate beam. So this is now conjugate beam, this is the conjugate beam, 6 by EI at this point, C point, right? Height with 6 by EI height at C point, right? So what is reaction at A? What is RA dash, and what is RB dash? We can divide it into two parts. There are two triangles, A C dash, C double dash. Two triangles are there, and another is this C dash, B dash, C double dash. The load of this triangle will be acting at this point. Say this is one part, this is another triangle, right? So load of this will be acting at this point, and load of two part will be acting at its center of gravity, like this, right? and this is triangle, so half multiplied by base multiplied by height. So finding reaction, so what is the load, what is the total load of this triangle, one triangle, triangle number 1, right, triangle number 1, what is the total load? So this will be equal to, suppose P1 and this is suppose P2. So what is P1? P1 is the load of A dash, C dash, C double dash. This is the conjugate beam, right? This is equal to half multiplied by, because it is a triangle, half multiplied by base is 3 meters multiplied by height is 6 by EI. So this will come out to be 9 by EI, right? And P2 will be equal to load of this triangle C dash, B dash, C double dash, C dash, B dash, C double dash, that is equal to half base multiplied by height is again 6 by EI. So this will be equal to 6 by EI. This is the load of the conjugate beam now, right? This is the load of the conjugate beam now. And this load will be acting at a point of this distance, say x1 bar from the end A dash, right? And this distance is say x2 bar from the free end, x2 bar from the free end, centroid of one beam, centroid of another part of the conjugate beam, right? So what is x1 bar? X1 bar, this is because it is from vertex, this is 2/3 of this total distance. So this is 2/3 of the total distance, which is equal to 2 meters, right? And what is x2 bar? That is equal to this 3 plus this part, 3 plus 1/3 of the total distance, right? So this is 3 plus 1/3 of the total distance is 2 meters. 2 meters. This will be equal to 3 plus 2 by 3. So this will be equal to 11 by 3 meters, right? So this is x1 bar and x2 bar. Now we have to find out reaction at point A dash and B dash, reaction of A dash and B dash, right? So finding the reaction, suppose we want to find out reaction. So to find out the reaction, take the moment about any point, say A point, about of this triangle, about this A point, and that moment should be equal to 0. So sigma MA dash will be equal to 0. So this will be implies all the forces, one of the forces RA dash, which is passing through A, so no moment of this. P1 has a moment of P1 multiplied by x1 bar. So P1 multiplied by x1 bar, say it is positive clockwise. Again P2 plus P2 multiplied by x2 bar, moment of P2 about A dash, and then RB dash. So this will be minus RB dash multiplied by total length of the beam, that is L, and that should be equal to 0. What is P1? That is 9 by EI. So this is 9 by EI multiplied by x1 is x1 bar is, that is 2 meters, plus P2 is 6 by EI multiplied by x2 bar, this distance, and that is 11 by 3, minus RB dash, we have to find out length, L is the length, and length is the total length of the beam, that is 5 meters, and that should be equal to 0. And from here we can find out RB dash. So RB dash, solving it, you will get RB dash, the reaction at B point, that is 8 by EI. So this is one of the reaction is obtained now, RB dash 8 by EI. Now we have to find out RA dash. Now these values are known to us, we have already discussed these values. Come to our point that the reaction at B point is 8 by EI. The load P1, what is load P1? Load P1 is the area of this triangle basically, which is conjugate beam is loaded with this triangle, right? So P1 here is basically the P1 here is the load of area A dash C dash A dash C dash C double dash, right? Divided by EI, divided by EI, right? Divided by EI, EI is already there, that need not to be known. So divided by EI, suppose, right? So it can be removed like this, right? So now load of area A dash C dash, this is right. And what is this unit of this? What is the unit of this? Or whatever the unit of these loads, right? So you can see here the load is given by half multiplied by base multiplied by height. Base has a unit of meters, height has a unit of kilonewton meters. So it will be having a unit of kilonewton meter square, meter square upon EI, right? So you have to remember that kilonewton meter square divided by EI, whatever is the EI, right? EI, whatever EI has unit. Upper the numerator has a unit of kilonewton meter square. This you have to remember. Similarly, P2 will be having a load of area, this another triangle, C dash B dash C double dash, C dash B dash C double dash, that is equal to kilonewton, this much kilonewton meter square upon EI, right? EI is there, right? And because it was kilonewton meter multiplied by this distance, because this distance is multiplied here, right? Because this area is basically the load. So area has a unit of kilonewton meter, which is the unit of bending moment, multiplied by the length. So it is kilonewton meter square divided by whatever is the EI, right? So you have to remember this thing. So all the reactions or loads will be having this unit, kilonewton meter square upon EI, whatever EI is, has the units. Now we have to find out RA dash, right? So for RA dash we can apply that for all vertical forces, sum of all the vertical forces should be equal to 0. So what are the vertical forces? In upward direction the vertical forces are RA dash and RB dash, and in downward direction the vertical forces are P1 and P2. So from here we can find out the P1 is known to us, P2 is known to us, RB dash is known to us, RA dash can be found out. So from here you can find out RA dash, the reaction at point A, right? And the reaction at point A will come out to be 7 by EI, right? 7 by EI. If you solve it, you will get this reaction, 7 by EI. So we have obtained the reaction RA dash 7 by EI, RB dash 8 by EI. So next reaction is known to us, right? Now what is the slope? What is slope? What is slope? According to Mohr's theorem, the slope at point A will be the shear force of conjugate beam, shear force of the conjugate beam at point A, right? Whatever is the shear force at conjugate beam at point A. And what is the shear force at point A? That is the reaction only, because there is only one reaction. So 7 by EI, so this is equal to 7 by EI, 7 by EI, right? Now so theta A will be equal to, in magnitude, now what is the unit of this? That is 7 by EI, whatever is the unit of kilonewton meter square, right? So we can apply now the value 7. Kilo can be replaced with 1000, Newton meter square can be replaced with millimeter square, so 10 power 6 divided by E. If you want to use it in Newton per millimeter square, E is given to us 2 multiplied by 10 power 5 Newton per millimeter square, and this is 10 power 8 moment of inertia millimeter square. So everything will cut down and you will get the value in radians. So you will get the answer in radians now, because we have used here kilo is replaced and millimeter square, so everything will cancel out and you will get the answer in radians, right? So what is the answer? 0.00035 radians. So this is one of the answer. The slope at point A is 0.00035 radians. So this is one answer of this question, right? Shear force at point A. And keeping in mind the units, because there may be a mistake if you are not using proper unit, right? So utilize proper units, right? Because this was a kilonewton meter square, right? Remember it. So we have converted into millimeter square, so that this millimeter square and this millimeter square can be cancelled out, right? So this is the slope at point A. Now we want to find out the deflection at point C. What is the deflection at point C? To find out the deflection at point C, what we have to take the moment of area, moment of this area about point C. We can use the moment of this area about point C, yeah, or we can find out the bending moment at point C. So basically the deflection under point C is bending moment of what? Of conjugate beam at point C, So what is the bending moment of the conjugate beam about point C? So that will be equal to bending moment of RA dash and moment of P1 about point C, because there are two forces. So RA dash, moment of RA dash multiplied by the distance, and this distance is 3 meters. So this is 3 meters minus distance of this P1, moment of this P1 about C point. So this distance is, this is 1/3 of the 3 meters. So this is 1/3 of the total distance between these points. So this is the YC. So this will be equal to RA dash. What is RA dash? RA dash is known to us, that is 7 by EI. So 7 by EI multiplied by 3 minus P1. P1 is known to us 9 by EI multiplied by, this is 1, right? Keep unit in mind that we have multiplied meter again to this kilonewton meter square is again multiplied by the meter, right? So this is now upper unit is kilonewton meter cube now, right? So you will get, what you are getting is YC will be equal to this is 21 minus 9 by EI. So this will come out to be 12 by EI. Keep in mind that the 12 upper numerator has a unit of kilonewton meter cube, because we have multiplied a meter here also, right? So upper part has a unit of kilonewton meter cube. This you have to keep in mind. So 12 multiplied by kilo is 10 power 3 multiplied by meter cube. If we convert it in millimeter, then this is 10 power 9 millimeter divided by E. E is given to us, that is 2 into 10 power 5 in Newton per millimeter square, and this is 10 power 8 moment of inertia, and solving it you will get the deflection at point C, right, in millimeter. Answer will come in millimeter, right? Solve it and you will get the answer, and this will come out to be 0.6 millimeter. This is the last answer of this question, right? So this is how we can find out the deflection and slope at any point using the conjugate beam.